Let's come back to science first. The first chapter, gravitation, we have already finished. Hardly few sums remain numericals that you try to solve. I hope that with the help of Navneet, you must have started studying science and other subjects also. And I told you yesterday to study the periodic classification of the elements. Today I will take you in one school. Acha, so surprise that during lockdown, how can we go to one school? The school of elements. As we know that in a class, the students sit according to rows and the columns. In the same way, the elements also, you will find in the periodic chart, are placed in their rows and columns. And there are different rows and different columns are there. Now the question is, why do we feel need to classify the elements? As we know that as we study science, in botany or zoology, we come across the different types of plants and animals and their species and all this we find. So to find their properties is very difficult, and that's why we feel need to classify them. So when we classify and when we classify them in certain categories, then the study becomes easy and one can easily understand. Similarly, we know that in science, in chemistry, there are 92 elements that occurring on the nature or the on the earth. On the earth, we have 92 elements. Very few exception. Almost all the elements react with one another and they form the compounds. As you know that in English there are 26 alphabets, but these 26 alphabets can give us the number of words with different meanings. Thousands and thousands of words are there with different meanings. Same way, we know that these 92 elements, most of the elements react and they form the compounds. There are different types of compounds. Even if we take water, earlier water was thought to be an element, but later on they came to know that water is not an element, but it is made of two elements, hydrogen and oxygen. Can you believe that hydrogen is a gas and oxygen also gas? And both when come together, they form water. And exactly opposite characteristics or exactly opposite properties. Hydrogen is explosive and highly inflammable, whereas oxygen, when something burns, then it supports. And when both come together, then they form water, which is neither explosive nor support combustion. On the contrary, they extinguish the fire. See, same way, number of compounds are there with different properties, and therefore we find difficult to study them. Hence, the classification is very important. Now here we find that during 18th century, John Dalton, the British physicist, he proposed some about the atoms, and in that he gave one statement that atoms have the characteristic mass. Each atom of an element, for example, if you take oxygen, hydrogen, all these, they have characteristic mass, and from that mass we can understand the properties. And therefore, when the earlier attempts were made to classify the elements, then they took the mass as a base of this, and you find that in a book they given the three scientists, Dobrynin, Newland, and Mendeleev. So these three, they took atomic mass as the characteristic for the property of the elements. And that's why here we find that they arrange the elements in increasing order of atomic mass. So you have to by heart this statement, very, very important statement. Whether it may be Dobrynin, Newland, or Mendeleev. But the beginning of this is they arrange the elements in increasing order of atomic mass. Because you will find that modern periodic table is based on this only. Arrange the elements in increasing order of atomic, but instead of mass, here atomic number is there. Atomic number. When Dalton proposed this about atomic mass, that time the atom was not properly understood. Dalton supposed that atom is indivisible, but later on in 19th century, atom was divisible, and in atom we know that electrons, protons, and neutrons present in that, and therefore we know that number of electrons give us electronic configuration, and in electronic configuration, the number of electrons in the atom's orbit is the valency of the atom, and from the valency we get the property. So we can say that number of electrons we give the configuration, and from the configuration we get the number of electrons in the atom's orbit, and from the number of electrons in the atom's orbit we can find out the properties. So we can find that properties of the element depends on number of electrons in atom's orbit. So number of electrons in the atom's orbit determine the properties of the element. To find the number of electrons mean number of protons, because electrons and protons same, and number of protons is the atomic number. So ultimately find the atomic number is the most characteristic property of the elements than atomic mass. But earlier they took atomic mass, and that's why some anomalies, some drawbacks remain in their table. And what drawbacks remain and how they earlier classified the elements, that we'll see first. The first attempts were made by Dobrynin. He was a German scientist, and he arranged the elements in increasing order of atomic mass, and he made the triads of the elements. Triad means the group of three elements in such a way that they will have similar properties, and he found that he made the triads, for example, lithium, sodium, potassium, one triad, calcium, strontium, barium, second triad, and in this way he prepared the triads, and he found that arithmetic mean of first and last was nearly or approximately equal to the middle one. For example, in the triad of first, lithium, sodium, and potassium, we know that lithium has atomic mass 6.9 and potassium has 39.1. So it divided because we know that arithmetic mean. So whenever we find the mean in arithmetic progression, and if there are three numbers are there, then mean is the sum of the first and last divided by 2 is the middle. That is the mean. And therefore, if you take the addition of these, the 9 plus 1, 10, carry 1. So this 9 plus 6. So plus 1, 10, 16, carried 1. 1 plus 3, 4 upon 2, and that is equal to 23. And you'll find 23 here. That is the arithmetic mean of first and last was the middle one. But approximately, I use the word approximately, not exact. Because why? Because they took the atomic mass. And atomic mass is not in series. As the number increases, atomic mass also increases. And that's why he has used approximately. Again, you'll find he made second triad, calcium, strontium, and barium. So calcium, strontium, and barium, they have atomic mass 40.1, 87.6, and 137.3 respectively. So you'll find that sum of the first and last is 40.1 plus 137.3 upon 2. Let's divide this. 1 plus 3, 4, decimal point. 7 plus 0 is 7. 3 plus 4 also 7. And 1. So 177 upon 2. And that is equal to 8 are 16. Again 8. 16. Carry 1. 7 will come here. So 88.7. So approximately find. Approximate. You'll find this. And in this way he made the triads. One more triad is also given here. Dobrynin triads. But he could not classify of all the elements, only few elements, though the 30 elements were there, but he could not give, his trial did not satisfy for all the elements, only for few elements. And that's why these were the anomalies, we can say, or the drawbacks of this dominant trial. After that, the next attempts were made by Newland. John Newland was a British scientist. During his time, in course of time, still more elements were discovered, and the number of elements during his time was 56. So again, he arranged the elements in increasing order of atomic mass. So this statement is very important for all these three, that they arrange the elements in increasing order of atomic mass. And then he found that every eighth element has the property similar to first one. So every eighth element has property, because during his time the inert gases were not discovered. And that's why every eighth element has a similar property. That means if you write here 1, 2, 3, 7, then again 8 will come here, 9, 10, 14, then again 15 will come here. Then as we know that in calendar, we know that 1, 8, 15, 22, these numbers come together. Same way, every eighth element has a similar property. But he could classify up to calcium. Though 56 elements were there, but he could classify up to calcium. And that's why it is called octave. Because every eighth element, as in the music, as we know that in music, sa, re, ga, ma, pa, da, ni, sa. So, sa, re, ga, ma, pa, da, ni. Again, sa comes here. You will find the sa comes here. Again, sa, re, ga, ma, pa, da, ni, sa. So 1, 2, 3, 4, 5, 6, 7 and 8. So 8th element will have same property with this. Again 1, 2, 3, 4, 5. Again 8 will come here. And in this way he prepares the octave. According to the music, and that's you find they are given the music here, sa, re, ga, ma, pa, da, ni, sa, or do, re, mi, fa, sol, la, ti, you will find. But he could classify up to calcium. Take note of this. This is the drawback of his. And besides, you'll find that in the table on page 17, cobalt and nickel, they had similar property with iron, but cobalt and nickel are placed with fluorine and chlorine. So fluorine and chlorine and cobalt and nickel, different properties. In spite of having different properties, he placed them in this with cobalt and nickel with fluorine, chlorine and bromine. So this is a drawback. Similarly, you find that iron is placed in T or Ni, mean last one,